I think when everyone sees the robotic arm, it is an anamorphic sort of machine, like looks like an extension of ourselves. For a lot of students, when we start to unpack this deeper history, both geometry, tool, labor, production, it adds much more scope to seeing it more than just a fabrication machine, but how much knowledge base we have as humans we have placed into these machines, and how far we have developed like our own techniques into a digital domain. I'm Steven Hoban. I'm the Director of Applied Technologies and a sessional lecturer at the John H. Daniels Faculty of Architecture, Landscape and Design. We're currently in the robotic high bay fabrication cell at the Daniels building. I did the MAS in the year 2015-2016, which was the inaugural year. During our time at the MAS, we built out a robotic cell to complete our work. And I think that experience and the level of integration really helped understand the complexity and all the inner workings to be able to build out the cell here at Daniels and to be able to spec both kind of robotic cell equipment and the external tooling. At the time, there wasn't many programs at all. Gramazio Kohler, I think, were the first group ever in architecture to bring a robot online in an architectural institution setting, and there'd been so much work that had already come out of the institution that when the MAS launched, and I knew that they were the kind of leads for the inaugural year, I knew it was something I wanted to be a part of. A lot of times when you use a robot in an institutional setting, it's already been set up for you. And there's a sort of a set of working parameters of how the robot's been defined, but we had to define all of that within the MAS to suit our design scope and our fabrication scope. So then when it came time to set up the Daniels robotic system, there was a high level of knowledge that I gleaned from my time in the MAS of how to sort of define what parameters we want to work in, what tools we want to work with, which wouldn't have been afforded to us if I had just worked on a pre-set up robot. I also teach within our technology stream, which is teaching how do we utilize computation, robotic fabrication, numerically controlled systems in both kind of design and design-based processes. My exact focus really tends to come into both materials and computational processes with materials, specifically within how we apply them in tools and technology in contemporary practice. My other side is I work a lot in reciprocal timber shells, looking at how we can use lightweight, short members in timber in reciprocal systems to create large spanning structures. So I enjoy timber. I think a deeper connection between kind of industry and research in timber fabrication is where I hope to see this beginning to coalesce within the North American context. Timber is such a rich resource here. My hope is that there'll be much more close collaboration between academia and industry to kind of drive the next generation of construction and design development.